Hi, welcome to Bits and Proofs. Today's question: why learn algorithms in the AI era? This is video one in a new series, Algorithms Across Languages, where we break down classic algorithms in Rust, Go, and Python side by side. But before we get into the code, I want to answer a question almost every software engineer is quietly asking themselves: what you'll get from this video? Why AI writes my code isn't a reason to skip algorithms. The exact bugs AI generated code keeps shipping to production. The mentor model: AI is a junior dev and you're the senior. The four habits of mind that algorithms train and where they pay off. And why interview bars are going up, not down, in the AI era. About 9 minutes total. No prerequisites, let's go. The honest question: AI writes my code. So why should I still study algorithms? In the next few minutes, I'll give you 5 reasons, and they're not the ones you usually hear. The short answer is this: because AI doesn't know when it's wrong. And neither do you unless you understand what good code actually looks like, what AI is genuinely good at, and what it isn't. There's a huge amount of work AI does genuinely well for us: repetitive setup code. Ask AI to write the boilerplate every project starts with: it does a perfect job. Clean code in any language. AI often writes more idiomatic code than senior engineers do. Routine tasks: talking to your database, parsing data files, calling an API. AI handles these instantly. Quick how do I do X lookups. The kind of thing you used to Google. AI gives you the answer faster than Stack Overflow. Converting code between programming languages. Good models do this really well. That's the easy 80% of programming, and AI just dissolves it. But here's where it falls apart: problems it hasn't seen before, anything unlike what it saw during training, code fast enough for your real world data. AI tends to write the textbook version that works on small inputs and falls over on large ones. Tricky bugs that pass all your tests but break in production. Knowing when its own answer is wrong. And the big one: picking the right approach in the first place. That last 20% is where engineering actually happens. And that's the part we have to bring in as humans. Looks right is the trap. When AI generates code for you and you look at it at a high level, it feels or looks right. That is a trap. Let me show you concretely. You ask AI, write a function to find duplicates in a list. This is what you get. It works, it's clean. You merge it into your team's main code after a quick test. It passes code review. It goes live. Then a real user passes a 100,000 item list, and behind the scenes, you've got 10 billion comparisons happening. Your code is suddenly 10 seconds slow. The fix is one line, but you only see the fix if you know what O of n squared means, the textbook label for code that gets dramatically slower as the input grows. The original code didn't have any of those words written in it. The bug wasn't in the syntax, it was in the choice of algorithm. Same trap, different failure. And it's not just about loops and big O. You ask AI to flatten a nested list, this is what you get. It looks like a textbook problem. It passes your tests. Then real input arrives, a config tree 5,000 levels deep, and Python crashes with a recursion error. The function called itself so many times that Python just gave up. The fix isn't more code. It's recognizing that recursion has a ceiling and rewriting it as a loop instead. That kind of instinct, knowing when the textbook solution won't survive real world input, is what algorithms train. And AI doesn't have it unless you ask for it. The reviewer problem: you can't see a bug if you don't know what to look for in your code. Reviewing other people's code is hard. Reviewing AI generated code is even harder. Why? O of n squared, code that gets dramatically slower as inputs grow. Off by one, a loop that runs one too many or one too few times. A race condition, two pieces of code stepping on each other when they run at the same time. Unbounded recursion, a function that keeps calling itself forever. These aren't interview trivia. They're the names of failure modes that take down real systems. If those words don't fire anything in your head when you look at AI output, the bug ships. AI generates code. You're still the reviewer. Think of AI as a junior developer. Here's the mental model that's helped me the most when working with AI. Treat the tools like a junior developer, eager, fast, can write a lot of code, can churn out solutions you'd take an afternoon to write, but still junior, and you are the senior. They do what you tell them. But if you don't know how to guide them, if you can't tell them what correct looks like, then they don't know what to do either. The senior responsibility doesn't go away. With AI in the loop, it actually matters more. AI is an amplifier, not a replacement. Engineers who understand the fundamentals ship faster with AI. They ask sharper questions. They make AI work the right way. They catch its mistakes before production does. Engineers who don't end up shipping plausible looking code. Code they can't defend in review. Code they can't debug when it breaks. Same tool, same junior in the loop, 10 times different outcomes. The difference is what you, as the senior, brought to the keyboard. What algorithms actually teach? 4 habits of mind that show up in everything you do as an engineer. Breaking problems down, taking a fuzzy problem and turning it into pieces you can actually solve. Computer scientists call this decomposition. Predicting the cost of your code, figuring out how slow it gets as the input grows before you ever run it. The textbook term is complexity reasoning. Weighing trade-offs, time versus space, simple versus fast. There's no free lunch in software, and algorithms train you to see the price tag on every choice. Proving why your code works, being able to explain why your code is right, not just that it passed the tests you happen to write. Where these habits pay off. Designing how an app fits together. Making database queries fast. Programs that run across many computers. AI training pipelines. And the one I really want to call out, reading AI-generated code. Because if AI really is a junior dev, then code review is where the senior earns the title. And honestly, beyond software entirely, once you start thinking algorithmically, you'll catch yourself decomposing problems at the grocery store. As an engineer, you're still on the hook for what AI ships under your name. None of these skills expire when the next model ships. Interviews still test algorithms. Top companies are more selective on fundamentals now, not less. Something surprising is happening with how top companies are interviewing. And stay with me even if you're not job hunting right now. Their reasoning is simple. If AI handles the easy 80%, they only need engineers who can do the other 20. The bar didn't go down. It went up. The 5 reasons in one slide. Let me bring all 5 threads together before we close. First, looks right is the trap. AI ships plausible code that hides real bugs underneath, and those bugs live in the choice of algorithm, not in the syntax of the code. Second, you can't see a bug you don't have the vocabulary to spot, and algorithms give you that vocabulary. Third, algorithms train 4 habits of mind, breaking problems down, predicting how slow your code gets, weighing trade-offs, and explaining why your code works, and those habits transfer everywhere, including reading AI code. Fourth, AI is an amplifier. Engineers who've built those habits ship 10 times better with it. Engineers who haven't ship code they can't defend. And fifth, the interview bar went up, not down. Companies want the 20% that AI can't do. 5 reasons, different angles. Same conclusion. The takeaway, algorithms aren't competing with AI. They're the lens that makes AI useful. Learn the fundamentals. Use the tools. Ship better code than either you or AI alone. Thanks for watching. Subscribe so you don't miss what's coming next. And share your opinion in the comments on what you want to see next.